Bright QT. Every student matters.
Hello students, my name is Sanjay Jain. Today we will study about some more criteria of congruence of triangles. Right, till now we have studied about side angle side congruency rule, which we accept as obvious universal truth. That means the axiom, right, which doesn't require any kind of proof. Now based on that we prove that angle side angle congruency rule is valid, and now we will study about some more rules like side 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 congruency criteria and then right angle hypotenuse side congruency criteria. So let us start with SSS congruence rule, which means side 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 congruence rule. If three sides of one triangle are equal to the three sides of another triangle, then the two triangles are congruent. What I mean is, let us say these are two triangles that we have, triangle ABC and triangle PQR. Okay, let us say this side is equal to this side, this segment is equal to this segment, and AC is equal to QR. Okay, if three sides of this triangle are equal to three sides of this triangle, then these two triangles are congruent. So triangle ABC will be congruent to triangle QPR. Okay, and you always take care of the correspondence while writing this congruency. Okay, in this AB is equal to QP, BC is equal to PR, and AC is equal to QR. Okay, so now let us prove it using some construction. Let us say we have got these two triangles ABC PQR. Okay, and AB is equal to PQ, BC is equal to QR, and AC is equal to PR, and now we need to prove that triangle ABC is congruent to triangle PQR. Okay, so to prove that triangle ABC is congruent to triangle PQR, now what is given in this question is that all three sides are equal. So AB is equal to PQ, BC is equal to QR, and AC is equal to PR. Okay, and I want you to do a construction here, construction. Whatever this angle is, angle B, I want you to draw the same angle here, right, and extend this side. Okay, and you will extend this side in such a way that it is equal to AB. Okay, so let us say this much portion is equal to AB, so I join this point with R. Let us say this point is M. Okay, so I have taken angle RQM equal to angle ABC and QM equal to AB. Okay, this is what I have constructed. Now let us start the proof. Let me give you an idea why I have taken this angle equal to this angle, because we know side angle side congruence rule says that if two sides and included angle of a triangle are equal to two sides and included angle of another triangle, then these two triangles are congruent. Now look at these two triangles. This side is equal to this side, right, and this side BC is equal to side QR, and included angle B is equal to this included angle Q here. So in triangle ABC and triangle MQR, AB is equal to MQ, right, by construction. Angle ABC is equal to angle MQR, and this is also by construction. and side BC is equal to side QR. This is given in the question. We started with this information, okay, that all the three sides of this triangle are equal to the three sides of this triangle. So now two sides and included angle of these triangles are equal. So by side angle side congruence rule, I can say triangle ABC is congruent to triangle MQR. Okay. So once I have proved that these are congruent triangles, I can say by CPCT, that is corresponding parts of congruent triangles are equal. So by CPCT, I can say that side opposite to this angle, that is this side, is equal to AC. So let me mark it by these three bars here, right, which shows that this side is equal to this side. Okay, right. So now this side is equal to side PR. Let me draw this line PM here. Okay. Now look at this. This side MR is equal to side AC. Okay, but AC is equal to PR. So PR and MR are also equal. What I am saying is MR is equal to AC by CPCT, but AC is equal to PR. This is given in the question. So I can say that MR is equal to PR. Okay. Now look at this triangle. Triangle PRM. Triangle PRM. This angle is equal to this angle. Why? Because these are base angles of triangle PRM, which is an isosceles triangle. Similarly, triangle PQM is also an isosceles triangle. So the angles opposite equal sides will be equal. So this angle is equal to this angle. Now if you notice, angle P, the complete angle P is equal to angle M, because both are theta plus alpha, right? So what I can say from here is that triangle QMR, okay, let me write everything what I have said. In triangle PQR and triangle QMR, in triangle PQR and triangle MQR, I can say that PQ is equal to QM, PQ is equal to MQ or QM, right, because we have constructed it in such a way, and PR is equal to MR and PR is equal to MR. This we have shown, okay, by CPCT, by this comparison here. So now this side is equal to this side and this side, and included angle is also equal, which we have shown by using the property of isosceles triangle, that angles opposite equal sides are equal. So angle P is equal to angle M. Angle P is equal to angle M. Hence, by side angle side rule, triangle PQR is congruent to triangle MQR. Now see, triangle PQR is congruent to triangle MQR, and triangle MQR is congruent to triangle ABC, right? So if one thing, let us say x is equal to y and y is equal to z, then x will also be equal to z. Now if triangle ABC is congruent to triangle MQR and triangle MQR is congruent to triangle PQR, then triangle ABC will be congruent to triangle PQR. Hence I can say triangle ABC is congruent to triangle PQR. Okay, so what I have used in this question is to prove that side congruency rule is valid. What I have done is I have taken two triangles ABC and PQR with equal sides. Okay, then I did a construction. I constructed this angle here and cut side QM equal to side AB. Now when I did that, this triangle QMR became congruent to triangle ABC. Why? Because two sides and included angle, two sides and included angle became equal. Okay, so now I proved that triangle ABC is congruent to triangle QMR. Now what I want to do is I want to prove that triangle QMR is congruent to triangle PQR. Okay, that I did by using two facts. One, that when triangle QMR is congruent to triangle ABC, corresponding parts of congruent triangles will be equal. So AC is equal to MR. Now I have got two isosceles triangles. Let me change the color to show it. Now I have got this isosceles triangle. Okay, another isosceles triangle is this one. Alright, so the base angles are equal. These two angles are also equal. So their sum is theta plus alpha, and this angle, this complete angle, is also theta plus alpha. Now looking in these two triangles, again by SAS congruency rule, I can say that triangle MQR is congruent to triangle PQR. Okay, now once I have shown that ABC is congruent to MQR and MQR is congruent to PQR, I can say that triangle ABC is congruent to triangle PQR. Okay, so this is side congruence rule. Now let us study about another rule, which is RHS congruence rule. RHS means right angle, hypotenuse, side, right? So if in two triangles, these two triangles are right angle triangles, right? If in two right angle triangles, hypotenuse and any side, hypotenuse are equal and any side is equal to any side of the other triangle, then we will say that these two triangles are congruent. What I mean to say is, let us say we have got two triangles. If I say that these two angles are 90 degrees each, and this hypotenuse, which is opposite 90 degree, is equal to this hypotenuse here, and any one side, let us say take this side and this side from here, right? These two are equal. Now these two triangles are congruent to each other. Okay, this is what we will prove or we will understand about it. Now look at it. If you look at it from your common sense also, if this is hypotenuse H, this is, let us say, perpendicular P, and this is B, and let it be H because I have taken it equal to this hypotenuse, and this side is equal to this side, so let me take it as B. Now look at this side P. What is P? P is, by Pythagoras theorem, it is equal to H square minus B square square root, right? And look at this side here. This side is also H square minus B square square root, right? So if this information is given that in two right angle triangles their hypotenuse and any one of the sides is equal, then we can see it through our common sense that if this much information is given, all the three sides will be equal. Okay, if this and this are equal, then the third side will definitely be equal. So RHS congruence rule is just another form of side congruence rule. Okay, if you want to prove it geometrically, then you can take these two triangles. Okay, these are 90 degree angles. Let us say this side is equal to this side and this hypotenuse is equal to this hypotenuse here. This is triangle ABC, this is triangle PQR. Okay, I am not writing all these steps here, I will just tell you the method to prove it geometrically. So now
you do a little construction. You extend this side PQ in such a way that QM is equal to AB. So this side I have taken QM as equal to this side. Okay. Now join M with R. Now look at these two triangles. This by construction is equal to AB, and this side was given equal to side BC. Okay. And this angle is 90 degrees because we have extended this straight line here. So this angle is 90 degrees. Now by side angle side congruence criteria, I can say that this triangle ABC is congruent to triangle MQR. Okay, like we did in SSS congruence criteria. So it is the same proof, right? Same kind of proof. Now by CPCT, I can say this side AC is equal to this side MR. So let me mark it by these two bars here. So this side is equal to this side. Okay. Now if this side is equal to this side, now you look at this triangle, triangle PQR. PR is already equal to AC because it is given. Now it is equal to MR. So this is an isosceles triangle now. So base angles are equal. So if this is theta, this will also be theta. Okay. Now two angles and a side, any side can be equal, because if two angles are equal, the third angle will also be equal. Now we have proved that two angles of these two triangles are equal. Hence I can say the third angle will also be equal. So if this is alpha, this will also be alpha. So by angle side angle congruence criteria, I can say triangle MQR is congruent to triangle PQR. Hence triangle ABC is congruent to MQR, MQR is congruent to PQR, so triangle ABC is congruent to triangle PQR. Right? I hope you have understood this and you can write all these steps yourself. On the similar lines as we have written SSS congruency steps. So first thing I did was I proved this triangle congruent to this triangle. How? Because I constructed this side QM equal to AB, and this angle is 90, this angle is 90. So by side angle side congruence rule, I proved that this triangle ABC is congruent to triangle QMR, and by CPCT I said AC is equal to QMR, right, and MAC was already equal to PR. So if these two sides are equal, this became an isosceles triangle, and the base angles of an isosceles triangle are equal. So theta and this theta. Third angle, when two angles of two triangles are equal, the third angle has to be equal. So this angle is alpha, this angle is alpha. Now you can clearly see by angle side angle congruency rule, you can say that these two triangles are congruent. Hence the RHS congruence criteria is proved. Okay.